Hi, good evening. Thanks so much for joining us today for today's virtual discussion on scale, speed, latency, accuracy, and resiliency. Have them all. My name is Shomik, and I'm glad to be your host and moderator for this evening. Now, organizations of all geographies as well as sizes are increasingly turning to data to gain business insights. They're trying to improve their decision making and gain that extra edge in the drive to deliver hyper-personalized user experience. The appetite for data, therefore, is only going to get bigger, much bigger. And organizations' IT stack must not only be able to deliver data crunching at speed, it must also be able to scale up and out depending on business needs. Now, resilience and latency are non-negotiable in today's hyper-competitive environment. Let's take Amazon for an instance. They found out that every 100 milliseconds of latency costs them 1% in sales. So today, we are going to learn how IT leaders, such as yourself, can enjoy the best of both worlds. In today's webinar, we've got a lot of ground to cover. So among our discussion points, we're going to be talking about how are they currently playing the balancing act between speed, scale, and accuracy and resilience? What kind of challenges do IT leaders face when trying to deliver on both fronts? And why conventional IT infrastructure and databases fail to achieve resilience, agility, and scaling capabilities. And joining me today is Fahad Khan, the Sales Director for the APAC region at Volt Active Data. Fahad, thank you so much for joining us today, and it's an absolute pleasure hosting you.
Thank you, Samik. Thank you. Thanks for the introduction. I'm happy to be part of this webinar and be present today. We also have our field engineering CTO, Dheeraj Ramela, join us. I would also like to bring him up on this presentation and have a conversation with him.
Absolutely. Dheeraj, thank you so much for joining us. And folks, Dheeraj is the Chief Product Officer at Bold Data. Dheeraj, how are you?
Very good. It's a bit early, sorry.
All right.
Just a minute late.
So we've got an exciting, discussion ahead of us. I'm sure there are a lot of people out there wanting to know that, how can they get the best of both worlds and not having to choose between scalability and resilience and latency and accuracy. And, I'm hoping you and Fahad could give us that key to the castle. So without further ado, I'll pass it on to you guys. Over to you, Dheeraj.
Okay. So let me just pull up a presentation that I prepared just to have a backdrop kind of a thing. Thank you for this opportunity, obviously. One of the things that we've actually seen is when you talk about real time, right? So when you talk about low latency, a lot of the times people think of a point job that needs to be done, right? So think of it as a storage, how fast can I actually store? How fast can I get the data back? Or issue a query, and how fast am I able to get the results for a query back from a data store or an API or whatever it is. But what we've seen from working with customers is that it's not just storage for low latency, right? So when you look at end-to-end latency, it's a full process that needs to happen, being able to ingest the data, store it, aggregate for some kind of a KPI that you're monitoring to understand your business health and compare it with what would be considered normal and acceptable. And is it deviating? If it's deviating, how much did it deviate by? And use that knowledge to make a decision based either on a static set of rules or using machine learning. So we internally call it adaptive decision automation. So thinking about a set of rules augmented by machine learning models and using that to make decisions, and the outcome of the decision pushing some actions. So this whole complete, we call this wheel of success. I know it's corny, but it's the wheel of success to say how do you make successful decisions? But this complexity, what is it actually driving, right? So there are several factors that are happening in the market, both on the technology side and on the business side. Like, on the technology side, you have ML and AI. Like, I mean, if you are not hearing about this, like either you have your radio off or something like that, right? So it's everywhere, it's there. Then the convergence of IoT and edge, like, the sensor-enabled sense control world of IoT is there. And then now that's also like expanding to places where just the introduction of the sensors is going to make things change. So video cameras have actually come into play, like observe control kind of a pattern. So IoT and edge coming together to create a new area of decisioning, low latency again, right? So it's all about latency. And 5G, Uber connectivity, and what are the drivers for 5G? High density, like a million devices per square kilometer, and under 10 milliseconds communication. Data is all converted into streaming because it's not like question and answer anymore. The data is coming so fast that they're coming in as streams, and then you need to address that streaming data. Advanced analytics, obviously, big data is a very mature space. How do you take that to the next level is the question that's going to be answered, in the newer context. On the business side, IT data and operational data used to solve customer-related, consumer-related challenges and operations-related challenges. But together, they need to be used to improve upon your customer experience, for example, right? Like, so there are only three real questions in any given business. How do I improve my revenue? How do I decrease the revenue leakage? And lastly, how do I do this operationally efficient, right? Like, so when these three questions get answered, you're having a good business, basically. So now, some of the use case patterns that we're actually seeing, when thinking about speed, scale, low latency, making your decisions that are accurate and correct, without compromising on your resiliency, being able to run the business 24/7. That's a really, really important thing, going forward, because majority of new businesses that are created are global businesses, right? So when you have global business, you need to run it nonstop, geographically distributed, and 24/7. So what are the use case patterns that we are seeing? We talked about those three, right? Like, so improving revenue, hyper-personalization, right? So decreasing revenue leakage, fraud prevention, policy-based accounting, and then how do you do operational efficiency, process automation? And obviously, like we talked about, the adaptive decision automation and digital twins. Digital twins is a really interesting space because when you really think of it, today, digital twins are representing people, process, and technology and systems. But it's only representing a state machine of how are things happening, what is it doing, and use that for A/B testing your newer business rules, for example, or learning from machine learning and big data analytics. But that's about to change, like, because these digital twins not only are knowing about the current state, but they're also knowing from the machine learning what is the predictive and prescriptive rules that are actually coming into play, and use that to control the physical twin and take actions based on these decisions. Okay. Now, it's not a curious experiment. It's not like, oh, like, let's do something fun, like, because this is new technology, and that's not the case, right? So there's a tangible value when you really think of it. Like, these are some of the metrics from our customers, like one of the telecom operators in the Southeast Asia region, they moved from 200 milliseconds decision making to making decisions under 7 milliseconds. That shift from near real time to absolute event time real time allowed them allow their customers to improve the operator's offer acceptance rate by 253%. That's not a small number, right? So when
Right. And it's only a question of a few milliseconds, in fact. And look at the effect it can actually make on business.
yes, yes, and one of the key things that I've noticed working with the customers is that the few milliseconds determines if your data decision action chain is correct or will be eventually correct or absolutely wrong, right? So the
Right.
closer and closer you get to the event creation time. So when you really think of it, I know I come from a data standpoint, but we work with an ecosystem of partners. The reason is end-to-end latency is, we saw that wheel of success, right? So that's the data processing part. But there are other elements too, like, how fast are you able to transport the data over network? How fast are you able to move through, technology layers before it gets to the data processing layer? And suddenly you're looking at the wheel of success. But what happened before that? How fast are you able to get that data to that processing layer? So end-to-end latency is a very comprehensive thing. And with that in mind, we've been actively working with an ecosystem of partners. So we are coming as a family to address the problem in a holistic manner. Okay. And this is another example. I needed to put it as fraud management, fraud prevention. I guess it's a cut and paste error. Sorry about that, the hyper personalization on the topic. But it's about fraud prevention, right? So this is card not present transactions. For each of these card not present transactions, one needs to apply nearly 2,000 rules for every one of them under 30 milliseconds. And what has this actually yielded? A reduction in fraudulent transaction completion by 83%. When you really think of how many billions, how many trillions of dollars are actually being wasted, or responsibility being shared to eat that cost between a retailer and the card company, that's a very large number that you're actually reducing. Okay. Policy-based accounting and charging. This is more in the latency space. The accounting needs to be accurate. You cannot compromise on that, right? So it's just period. Either you're actually giving away free services or you're upsetting a legitimate customer by making a wrong decision. But to do this in an environment like telecom, you need to be absolutely within that 10 millisecond range. But if you add a lot of complexity to your processing, then you're going to break that SLA. Breaking that SLA means either you're losing money or losing a customer, one of those, right? So in one of the cases, we've seen a reduction from 40 plus milliseconds to under 10 milliseconds, and bringing them back into compliancy level where now they're actually able to participate in RFI, RFP successfully and win customers. Okay. So why is this latency happening? Why is this breakage? And why are we not able to meet this low latency and high consistency states or requirements in a more conventional manner? When you really look at it, there are 4 key capabilities that need to come into play together. It's the ability to store the data really fast, ability to process the data fast, application of business rules, and KPI aggregation. We saw that in the wheel of success. If you break them down, there are 4 key product categories that come into play. Typically, enterprises would say okay, let me go to my favorite analyst, Gartner or Forrester or whoever they trust, and let me pick these categories and find the top player in each of these and say we do this, or evaluate them at least, being jovial a little bit, but or on the other hand, find an Apache project, because if you really look at open source projects, they stem from a point problem, and that point problem is a common problem, so a lot of key contributors come in, and it becomes really successful. So you take these point solutions and stitch them together. the problem with this is by adding so many layers, you're creating a very chatty system. Like, chatty meaning like every layer is talking so much to each other that you're sending data back and forth, getting answers back and forth, communicating over the network back and forth. All of this adds baked-in latency. But in the example that we saw about 40 milliseconds to 10 milliseconds, that was one of the key problems for them, right? So
Okay.
then you have 4 of these technologies, and they all are receiving data at various times. At any given point in time, you ask a question to one of these layers, it talks to the other 3 layers. I wouldn't say like there's no guarantee, but there is very low amount of guarantees that all 4 of these systems have the same version of truth, the same view of the world in data, to say like, hey, we're all actually operating on the same foundational fact set, right? So that inconsistency leads to each layer could be eventually consistent, but when you actually have to put them all together and everybody is eventually consistent, nobody is currently consistent, right? So, and that leads into challenges of the data decision action chain being broken with incorrectness. And another key trend, we talked about, IoT edge confluence and convergence. So when you're moving this intelligence closer and closer to your data source, the infrastructure available at the edge becomes very constrained, right? So it's not like cloud where like, oh, just I'll write some rules, and then anytime that rule gets invoked, I'll scale out even more instances. Nobody cares. I'll just keep paying. That's not the case with edge. Like, you have very limited amount of resources, and you have to use them very wisely, so to speak. I mean, so how do you do that? With these kind of a minimum 4-layer approach, each layer would require resiliency, right? So meaning it needs to be resilient to failure handling and business continuity. So how do you take that? If each layer is resilient, now make it 3x hardware requirement, and putting it all together, you're starting to really strain the resources at the edge. Not just that, people, right? So how many developers do you need for each of these technologies? How many people do you need for testing, moving through development, staging, testing, production, and failure handling, what is that? Figuring out what problem has occurred, and how do you establish business continuity and failure handling between these layers, right? So, and all of that increases the total cost of ownership. And, as I explained, it's not just the hardware, it's people, time, hardware, time to resolve a problem, mean time to recovery, everything takes a hit. So what would be the best practices? Okay,
Dheeraj, sorry, just before we get there, just give me one sec. I saw one of our attendees raising their hand. I think it was Gaurav. Gaurav, if you have a question, or if anybody has a question, please do share your questions with us in the Q&A box. You'll find that at the bottom of your screen. You can type in your questions, and then we'll take them as we go along. And Dheeraj is more than happy to answer your queries.
Absolutely. So, I mean, if you notice the presentation, it's a storytelling kind of a thing, right? So I'm not here to sell anything. I'm just basically walking you through the journey that our customers have gone through with us and what we have learned. So if someone has similar challenges, obviously we are always open for a discussion and see where it takes, right? So you mentioned there was a question?
Yeah, I mean, I was just wondering, Dheeraj, for the longest possible time, companies were being told, or IT teams were being told that you cannot eat the cake and have it too. But at some point, somebody just stood up and say, why not? Was this shift, gradual over the years, or is it something that we're seeing in the last 5 years? There's been a greater demand to, want all factors, scalability, accuracy, reliability, resilience, etc.?
It was gradual, and then it's overnight, right? So because if you really look at it, like, just managing data, like, the file system was fine, and then like mainframes, and then relational database. Relational database ruled the roost for the longest period of time, and then the scale problem came up. Like, the whole internet, the internet 1.0, or actually 2.0, like, Web 2 basically started making the internet applications create a scale problem. And that scale problem gave the domain to NoSQL, right? So key value and NoSQL came into play because enterprises, all they cared about is, oh my God, like there's so much data getting generated. Like I don't want to lose it because I'm going to use it at some point. I will be able to use it. So let me just collect all the data. And because relational databases could not do that, they were resorting to say, okay, let me just collect the data. But that if that means like I'm not going to be able to query the data or index the data, like that's okay. Let me just collect it. And NoSQL came into play, or key value store. And then as time progressed, this Web 2.0 paradigm basically started creating, we need to know the answers now. Like it's not like you can actually go do it sometime else. Like, the whole Hadoop ecosystem, storing the data for big data analytics actually happened. And then, once you actually shift from there into making decisions and taking actions and answering questions, it started with answering questions, right? Like so,
Right,
and
right.
that was actually a little bit more shorter time frame. But as the connectivity and the entrepreneurial spirit of the humanity started increasing, it started becoming more and more overnight. Like, the scale problem is addressed. Now let's figure out how to bring back the values of the relational databases back into the system. What are the values of relational database? Consistency, reliability, resiliency, and immediate well, actually, we talked about immediate consistency, right? So that we need to bring that back. If you look at like every single one of these NoSQL technologies and key value technologies, even streaming technologies, they're saying like, well, we have to have like a SQL-like interface. You know what's most like SQL? SQL, right? So it's you take SQL and then say like, oh, let me actually get like a KSQL on it. Like, that'll be interesting. Like it's just slightly different, but and then or CQL or MQL. It's like, dude, like SQL is already there. It's an
Yep.
established set of patterns that have been addressed maturely. So let's actually bring that knowledge in. So you're seeing this quite a bit of bringing back what we lost by leaving the relational database into the new world. So it's slowly progressing there, but there are options. Like for example, like Vault. The genesis of Vault was Vault Active Data was how do we bring in the scale of NoSQL databases and bring in what's relational database as relational, not relational like, not SQL like, but actual SQL, actual relational, but manage the NoSQL data scalability, the horizontal scalability, right? So we'll get into Vault, like if anybody is interested in knowing more about Vault, but just wanted to share what's happening, here in the data world itself. Like, so given that shift of let's bring back the value, what are the best practice considerations, right? So people think of data like data is the oil, data is the oil. You're not going to do anything with the oil if you don't have an engine to use that oil, right? Like, so the decisions are the engine. So the decisions are a better metric, better angle of thinking than just data. Now, how can I actually use this data really, really quickly? Obvious next answer is like, shortest path from creation to decision, right? So it's and we talked about this, end-to-end latency is not just a singular problem. It's network infrastructure, data processing layer, and physical topography. All of these need to be taken into consideration to ensure you have end-to-end latency. And given the scale at which things are happening, don't think of let me just store the data, and then I'll build an application that comes in and queries it. And don't wonder why it's taking so much time, and don't wonder why you're getting the wrong answers, because you're throwing a lot of data here and you're asking a point-in-time question here. This is not, the question's answer is not going to reflect the last given event's arrival. So think of your whole application and event-driven mindset. And if my industry, and this is a rhetorical question, I think every industry will have a role at the edge. What is that edge? Could start differing, right? Like, so you have on-device edge, on-prem edge, network edge, mid-haul edge. There are so many areas that you can actually think of. A trader's desktop is an edge, a mobile phone is an edge, but figure out what edge is for your business and refactor your business into like what makes sense to run on the edge and what makes sense to run on the cloud, and what will that edge cloud relationship look like. We need to figure that out for each and every business, for each and every application. It's different, and that needs to be figured out. And now this edge cloud, you can really think of edge being fast data and cloud being big data. And how does that actually look like? And how can I actually create an adaptive decision automation? This is a term that we use and more recently created, I guess. So don't search for this. Maybe you'll find something. But basically what it is I want to have certain set of rules that are standard method of procedure. You bring a new employee, you train them. That's your method of procedures, right? So take those decisions, automate them. Now you augment that with adaptiveness by bringing in your machine learning model into this decisioning process to say, now make better decisions, better decisions, better decisions. Why is it important? To avoid false positives and false negatives. Because at the end of the day, if your adaptation of decisions is going to really upset your end customer and start losing customers, you foundationally fail at the purpose of having customers, right? So you want to make sure that you refine on the false positives and false negatives. I see there's a chat came up.
No, we don't have any questions yet.
Okay.
So they will start, throwing in their questions. I had a quick question here now. Dheeraj, it's a very interesting thing that you brought up. What do you host on the edge and what do you put on the cloud? What are some of the things that IT leaders? What are some of the questions that IT leaders need to ask themselves when they're trying to, take those decisions? What goes in the edge? What goes in the cloud?
That's a good question, right? Like, so, so I in my mind, when I work with our customers and like, I'm looking to guide them, like I look at it as like, okay, how close is a business process to the glass being what's viewable by the customer, right? So, and what's happening behind the scenes. So behind the scenes, typically it's okay because there is no interaction with the customer. Like, so look at all the touch points of the customers, look at all the touch points of your employees, and how much of these could be automated, right? So the human machine interfacing area, if you move that closer to the edge, that means you're taking a shorter round trip from an end device to a data processing layer and back again to the end device. So that's one foundational way of thinking about it. Now, obviously, once you figure that out, then you find all the supporting areas, right? So what are the areas that are supporting? Think of API integration, like, and the systems that expose APIs for inter-system data transference, like, because it's not monolithic, right? So it's all microservices. So when you think of microservices, where do these services reside? How are they exposed as API? And how do you bring that data together to satisfy this customer, employee, machinery touch point, right? So a non-compute participant in the business process, how does that actually have a touch point with the compute systems? So that will be your edge locality, right? So that from there, you can start spider webbing back into, okay, what are all the supporting systems? What are real-time support systems? What are going to learn from these. Like think of machine learning and AI systems that need to look at large amounts of data. They're not interacting with the customers right now. They just need to churn, figure out the wisdom and intelligence of that data, and concoct that into or distill that into a set of rules and then push it back at the edge. So that would be a good area of bifurcation, so to speak.
So thanks for sharing that.
Yeah. All right. So let's see, like a lot of the times, like, this is a foundational question. Like, I'm not trying to be like a preacher here, but like, really this helped me be able to think of data very clearly, right? Like, so what happened? It's in the past. So you're just sending a report, to somebody. Like, it's not even a real-time dashboard. It's just you're sending a report. What is happening? This is where you're starting to say, like, okay, what is happening in my business right now? Like, I can push a dashboard to an operational center, like a network data for knock or like, fraud or anything of that sort. I can put things up on a dashboard, but it's still HMI, human machine interface, right? So someone is looking at the dashboard, someone is knowing what that dashboard means, and figuring out like, oh, it went from green to yellow or yellow to red, and now I have to make a decision. I'm a highly specialized, trained person that has done this for 10 years. So like, I know exactly what to do. It's like, okay, that's sweet. But, you're having a bad day, you have a sprained ankle, you're going to forget some rules and like, you're going to make the wrong decisions, right? But that's what's happening, like show in a dashboard, and KPI aggregation. Then what will happen? This is where the big data starts coming into play, like predictive analytics, and using those analytics to say, okay, when I see these set of conditions develop, this has happened in the past, and I'm looking at the same set of conditions developing, so most probably the same thing will happen. So now you're able to predict. Then the prescriptive analytics comes in. Okay, these set of conditions are coming together, so this is going to happen. What do I do to capitalize in case of hyper-personalization? Or what do I do to avoid that from materializing and manifesting? Fraud prevention, right? So fraud prevention has a plethora of skins. You could think of bot detection, DDoS prevention, intrusion detection, surface area protection. So there are so many variety of things that you can actually do. And what do you do when something looks like it could happen? That's your prescriptive analytics, right? So now this is all good to know, but how do you put them to use? And that's where, is this happening right now? And what can I do about it? And that's your real-time data decisions actions chain, right? This brings the predictive analytics, prescriptive analytics, low latency decisions all together in the big data plus fast data manner, right? So why do we need to change things? So what are the changes in the compute systems, operational systems that is driving this need? We talked about this a little bit earlier, right? Like, so what is this overnight or is this slowly progressing? Like, it's the technological evolution is becoming more and more overnight, I suppose. Wi-Fi 6 and 7, like, better coverage and faster data, like, Wi-Fi 7 actually is pushing towards 10 Gbps. LoRaWAN is like fantastic implementations for buildings with iron walls and concrete rebars and things like that, where your radio waves cannot actually go through, like 5G and 6G. 6G is more brand management. The shift from sense control to observe control, like this is a term that we coined, but like, essentially what it is like, being your telemetry data, you're using it for sensing, temperature, pressure, whatever, right? Like, so then using that to send back control signals. Now, on the other hand, introduction of a sensing system could change the behavior of your overall system. So in those cases, you don't want to do that. And another other areas is like, commoditizing your technology. So you're not actually putting specialist knowledge inside each of these technological systems. So the example that I'm thinking about is AMR, right? So autonomous mobile robots. So you put in all the AI, ML, inferencing into the robot. Now the robot is very specialized equipment, and if something fails, replenishing that, the lead time becomes really a long period in time. So you can move the intelligence out of it and make the robot a commoditized object. It's a moving thing that has functionality to pick up and drop things, and it'll take commands from a central command for a floor, so to speak, like, a warehouse floor. You have several robots, and then you can have several cameras that are observing all of them, tagging them, and then controlling their movements and direction. Efficiency through automation. More and more systems are getting automated. Like, this is it's a double-edged sword, so to speak. Like, yes, businesses get to do things faster, so you're having happier customers, but you're also decreasing the number of employees. So there's a conundrum I don't know how to answer. Like, do you decrease employed number of people? What happens to them? But if you focus on that, what happens to humanity as a technologically evolving, organism? I don't know the answers for that. It's a very philosophical question, so I'll push that aside. Right, like, so consumer expectations have changed. Like, this is something that everybody knows. Like, I want it right now. And when I'm actually looking at something, I don't know what I don't know. So you should know what I don't know, and you should tell me what else I need to consider. Like, if I'm buying a TV for wall mounting, you should tell me that I need like a VESA bracket that actually goes behind it. I need these type of screws that go into the wall to hold the TV, and all of those things, like, the recommender system. So, and then, this take it one step further, like, it's not just completed products personalization, the products about to be created personalization. That's the industry 5.0, right? So 4.0 is about adaptive automation. But when you move it to industry 5.0, you're now looking at hyper-personalized manufacturing. Like, so nothing is created. It's all just-in-time creation based on customer expectations and requirements, so to speak. Okay. So, yeah. Any questions, like anything that you want to just surface up, Samik? And
I think we can take this question right now. It's quite interesting because we are trying to, have this conversation about what you want to achieve and then what you might risk losing. And that's exactly what Srimanto Chatterjee has pointed towards. So Srimanto is asking us, what are the trade-offs between reducing data latency at the same time you're trying to ensure security?
super good point, right? So security is not an afterthought anymore. Security needs to be intertwined into every layer of your operational processing, because because it's machine-to-machine interfacing a lot of the times. Like, the machine could be like a server just from API integration standpoint, or it could be a data creation machine to action taking machine, or a round trip. But in any case, if there is an interaction, it is interceptable, right? So that means every interaction that's making a business decision also needs to incorporate surface area protection. So surface area meaning, like, is this interaction an area that's exposed for attack, right?
Yep.
So now when you really look at like low latency, intrusion, so you're not actually saying like, okay, it's not authentication authorization matrix, like, all right, like, so we authenticated them, we authorized them, now they can go and play. It's like, nope. After that, there's spoofing problem, right? So after that, it could be code injection problem. There's so many ways that an intrusion can actually happen. And not only that, like, it's not even humans writing virus programs or attack or anything like that. It's all automated by AI, right? Like, so as the good things evolve, bad things evolve, and like, good things and bad things need to fight the same way. So it's the things to consider when you're really thinking about low latency. And this is where like the 2000 rules example I gave in fraud prevention apply in every form of malfeasance, so to speak, like, where the interaction itself has a business purpose. The business purpose is the smaller part, right? So all the things that could go wrong around that business purpose, you need to take them into consideration and build them into that sub 10 millisecond processing. or sub 30 milliseconds, whatever is actually making the most sense. So, because once you have actually entered the system, the miscreant, the API virus, whatever be it, like, once it enters, it can start self-replicating, and the propagation is very quick into the system, right? So security is not an afterthought. It needs to be built into your existing system as a weave, right? Like, so your regular processes and security considerations need to play together at every interaction point. Hope that helped. All right.
Yep.
So, we talked about this, right? So this is how we look at edge cloud relationship. Now there's a whole nother area that we can think of like edge relationship, but that's for another conversation. Or if you want to learn more about that, you can reach out to us and we'll talk what we've learned in that area, because it's such a wide topic, right? So edge cloud relationship, think of it as edge cloud, fast, big, decisions, analytics, right? So that can actually help you a little bit of a bifurcation. Obviously, there's more work that is pertinent to each of the systems, each of the applications that are being under consideration. Ow, something that got in my eye, sorry. Okay, all right, so this is something to remember. I always remember cute animal pictures. So like, when you have a composite architecture and you have every system that needs to do something and you need to keep them all in order, it's like the left-hand side. Like, this is how it is. Like, one thing goes wrong and then like you try to fix it and something else goes wrong. But being able to put them all together into a unified architecture that work together is, see how calm and peaceful on the right-hand side it is, right? So it's a symbolic representation, obviously, to get a chuckle out of people. But really, do you want heroes in your data center? Do you want heroes taking care of your systems? Or do you want your systems to not require heroes? Right. So that's the main consideration when you think of it. So we've put together, this is the Vault plug, I'm being blatant about it, like, but what we have done is actually not bring together a multiple set of technologies and combine them together, but rather actually have indigenously built, completely forged together technology, not even a stack, it's like one layer that does a lot of these things. Like, we talked about that whole wheel of success. So we have actually incorporated all of that and taken care of all the shortcomings that you would see in a composite architecture, and integrating with an ecosystem of partners, establishing relationships. So you could go to any of our partners or obviously talk to us, and we can bring the picture together, bring the right partners together to look at your situation and what will be the best approach to solve your challenges. And if Vault is not the answer, then so be it. We will let you know as soon as we can actually determine that as well. Okay, just to spur some of your imagination, use cases, right? So we look at the use cases and say like, okay, there are 4 main categories that we've actually determined, like augmented OLTP, augmented transactional processing. You have your data transactions, but with the data transactions, you need to do something more, like apply some logic, and that's your augmented OLTP. Then you have real-time streaming ETL, where data is streaming in, you need to do conditional logic application to that streaming data before you land it somewhere, right? So, and you need to do that intelligently, like think of compliance, 5G mediation, etc. Then ML augmented enriched decisions, this is the adaptive decision automation we were talking about. And then complex event processing. Complex event processing is really cool because it was always there. Like, it's the complex event processing has been there since 2000s. Like, but the applications are becoming so much more interesting nowadays. And in the light of low latency, consistency, and multiple streams of events arriving very, very rapidly, what kind of things can you do? Like, some of the use cases that we've actually seen is smart grid, smart meter management, asset and fleet management, road traffic management. This is actually very, very cool stuff. Like, it's traffic intersection safety, right? So it's not just based on the car load on the road, but you're actually also utilizing video cameras to determine people walking across intersections and figuring out people load and using that to intelligently cycle through those traffic lights. So you're preventing, the automobile infractions or being putting people at risk of an accident and things of that sort. And predictive maintenance, obviously, the last use case. This is an ever-evolving one, right? So it's like, do you wait till something goes wrong and then fix that, or do you actually prevent that something going wrong in your machinery from happening at all, and thus save not just the machine but also the personnel around you? Like, think of the number of accidents at oil rigs where the drill bit got too much temperature and then shattered, and then there were 2 people injured. Like, how can you avoid that kind of stuff? Like, literally life or death questions could be answered in a low latency manner. Okay. That's all I have for sharing today. We can leave it on this screen, I guess, like, just to keep the discussion going.
Yeah, absolutely. I mean, there are some questions that I had, and some questions that came through as well. Dheeraj, if you could elaborate a bit more on how this change in architecture could actually contribute to reducing the TCO. Been talking to a lot of IT leaders and CIOs, CISOs, both categories. That seems to be one of their top 5 priorities. How do you get down the TCO?
A lot of the times, like, when you really look at total cost of ownership, we discuss this, right? So it's not just the hardware infrastructure, it's like the hidden costs that actually come into play too, right? So the hidden cost could be just how many people do you need to babysit the system once it's actually in production? How many people do you need for the recovery part of it? That aside, when you look at like hyperscalers, the hidden cost is ingress egress, right? Like, so the egress part of it, at least, like, where you can put the data in for free, but like when you take it out, like every bit costs. Then how much of the storage is required? Like, I'm not saying hyperscalers are not necessarily like that's evil or anything like that, right? Like, so there's a role to play as to what gets done where. There are hyperscalers, there are scalars, right? Like, so there are other technology choices. Like, for example, like we're working with Lumen. Lumen has edge data centers. They work with hyperscalers as well, like, because you need like an edge and cloud. So for the edge, think of the paddles of Lumen Technologies in your world, right? Like, so these guys are having small data centers within 5 milliseconds reach everywhere. So, and the ingress and egress is free, right? So not only can you run the application right there in those data centers, but you can also have your own data center tunneled into their data centers and be able to get your data for free without having to pay extra costs. So like, this is just one example, obviously, right? Like, so when you think of TCO and how do you reduce the cost, you have to think of people, latency, and the latency. The reason I'm saying latency is the cost is not just running the systems.
Yeah.
The cost is also keeping the customers, losing the customers, right? If somebody else is actually able to have a better experience with some other enterprise, they're going to move there. That churn is actually, customer acquisition is a lot more expensive than customer satisfaction, right? So don't lose the valuable customers that you actually acquire. So that total cost, when you really look at it, like it's the cost and benefit, which could become the perceived cost. All of that coming together completes that picture. So these are some of the considerations that I've seen working with some of the customers.
All right. Now, Dheeraj, again, going back to my favorite slide in your deck, the one with the cats, for a company that's trying to transition from, having all of these disparate solutions or disparate IT tools working in silos, not talking to each other, and they're trying to move towards a unified approach at this point, what would be a good starting point? Could you just lay out a roadmap and, how do they go about that particular journey? What's the best approach?
Oh, that's a tough question. You are never going to do away with shadow IT, right? Like, so
Yeah.
the silos is one. Silos is the smaller beast. It's the shadow IT that's the other beast, right? So I've worked in companies where they just basically connect to the main database and have like a query that runs from an Excel spreadsheet, pulls the data, and they take that spreadsheet on their laptop and go home. Like, what are you doing? Your laptop gets lost. The data that you pulled in is on your laptop, and it'll be gone too. Like, so it's really the common architecture needs to be emphasized, right? Like, so in that company, I was actually at the architecture review board, and that was the biggest challenge for us. It's like, okay, don't look at data, like just bring the data to this common architectural area and expose all the data via API. So even the ingestion part could be API, but like, it's a API-based ingestion could become a lot slower than just pushing data in and then asking questions immediately, right? Like, so there's a small minutia there. But finding the common areas and breaking down your monolithic applications in each of the silos into things that can be used across there, like authentication is just an easy one to like point handset, like, then obviously in insurance, like adjudication could be another one, risk evaluation. So all of these could be exposed as APIs and create APIs that will be supporting the class applications, like whatever your employees are using internally or the customers are using externally. Those should be composable in a manner. But where do you start? It's people, right? Like, so you actually start with people in your organization to bring them together to say, how can we actually make this better and be able to have better efficiencies and scale inside? So let's first do an audit of what is in play and bring all the requirements and functions. So this is where the one more step actually comes into play, which is business process management, right? Like, so first map out your business processes, because at the end of the day, there is customer, there is revenue. Everything else is like, coming into it, going back, branching out of it, but these two are the endpoints, right? So you provide a service to a customer and keep them happy, you're making revenue. That's
Right.
it. That's what a business boils down to. Everything else in between is to make sure the customer is the happiest while you're maximizing your revenue. So now let's actually build that business process model and find the common grounds and then bring them together. And it's not just a technology problem. If someone thinks installing a system in their data center is going to do the magic trick, nope, it's a people problem, right? Like, so at least a people situation, I suppose. Like, obviously a person doesn't wake up in the morning and say like, I'm going to do something evil. Like, no, they did the best decision and action given a scenario in which they were put, and it organically becomes inefficient eventually, right? So, and it's that refactoring.
Right. And Hiraj, again, going back to the root of today's topic. Now, in your experience, you've got a lot of experience working with CIOs and IT leaders, out of which 11 have been right here at this company. In your experience, which of these factors are the most difficult to achieve? Scale, speed, latency, accuracy, and resilience. Which of these are the most difficult to actually get into control?
So it's very, I don't know if it's a trick question, but like, you take each of them, it's okay. Like, it's not too terribly difficult, especially the speed, scale, low latency. Those are not like that difficult to achieve independently. Consistency and resiliency is a very needs to be a well thought approach, and those are even individually would be the most difficult to achieve, amongst the five, so to speak. But when you put them all together, it becomes more of a holistic consideration than just saying like, oh, like let me just put a bunch of technologies that each would have all these five traits and then work. Each of them independently for a point problem could be the best. But when they all need to work together, then the definition of resiliency changes, right? So you're not talking about a single technology resiliency, you're talking about a system resiliency. And system resiliency is a lot more comprehensive. So in my mind, consistency and resiliency would be the hardest to achieve. And if anybody can actually help you walk through that process, I would say take full advantage of that, right? So
I agree. I mean, resilience has become a core topic among both IT leaders as well as CISOs and DPOs. So yeah, great points brought out there. I think we are done with the questions that we have from the audience. And yeah, I think we got to learn a lot. And of course, we got to learn the fact that you don't really have to pick or choose between either of these business objectives, but then you can have them all. It's just the right approach. And thank you again, Hiraj, for sharing those points with us. I'd also like to thank Fahad and audience. You've been, really attentive, and thank you so much for your participation. This is Shomik Ghosh signing off on behalf of ETCIO. Thanks so much. You have a great day ahead.
yes, thank you so much for the opportunity.
Absolutely. Thanks. Bye-bye.
Bye-bye.